All right, let's dive straight into this. Welcome back to The Explainer. Today, we're unpacking a really elegant and honestly absolutely essential dynamic in microeconomics, the behavior of cost curves. We're looking directly at the collision of two massive forces in production, average cost and marginal cost. By understanding how these two metrics interact, we basically unlock the secret to how firms evaluate their production efficiency. We're going to give you the exact three-step framework to master this entire concept, so let's get into it. But first, before we throw them into the arena together, let's set up the foundational characters of our story. First up, we've got average cost, or AC. This is simply your total cost divided by your total units of output, basically the per unit cost of all your fixed and variable factors. Our second character is marginal cost, or MC. This is the addition to your total cost from producing just one extra unit. A good way to think about it, marginal cost is the active, immediate force of the present moment, while average cost, well, that represents the accumulated baggage of everything you've produced so far. Here is our roadmap for today. We'll start by defining the cost curves, then we'll walk through the three phases of their interaction: the decline, the intersection, and the ascent. Finally, we'll tie it all together into the minimum point rule. Okay, starting with section 1, defining the cost curves. Let's take a look at the arena where these forces operate. Take a look at this. Notice the really distinct U shape of our average cost curve here. You might be wondering, why does it look like a giant U? Well, it all comes down to the law of variable proportions. At first, as a firm employs more variable factors on a fixed factor, the average cost falls. But eventually, and this happens every time, as you keep cramming variable factors onto that same fixed factor, the average cost inevitably starts to climb back up. So the curve falls, bottoms out, and rises again. And you'll notice the corresponding marginal cost curve shares that exact same U shape. So we've got two U-shaped curves sharing the same graph. The central question we really need to answer is, how exactly do these two specific costs interact with one another as production output increases along that horizontal axis? Which brings us perfectly into the first act of our play-by-play. Let's look at Rule 1, the decline. I want you to focus specifically on the left side of the graph. Notice that section spanning from the origin right up to the output amount marked OQ2. In this initial range, the marginal cost curve lies strictly below the average cost curve. And what's happening to the average cost during this entire stretch? It's falling. This gives us a crystal clear micro summary. When marginal cost is strictly less than average cost, the average cost is falling with an increase in output. Put simply, when marginal pulls down, average follows. Think about it. Because the cost of producing that next single extra unit is cheaper than the average of all the previous units, throwing it into the mix obviously drags the overall average down. But, it can't fall forever. Let's look at the climax of the graph where these two forces finally collide. We call this Rule 2, the intersection. Now zoom in exactly on point L. This happens right at the output level marked OQ2. Notice how the average cost has totally stopped falling, but it hasn't quite begun to rise yet. For just a split second, it is perfectly constant. And right at that exact minimum point on the average cost curve, the marginal cost curve intersects it. To really hammer home the significance of this, we can look at how the textbooks define it. The MC curve cuts straight through the exact minimum point of the AC curve. This illustrates a mathematical certainty. When marginal cost is perfectly equal to average cost, the average cost is at rock bottom, its lowest possible point. The extra unit costs exactly the same as the historical average, meaning the overall average doesn't budge one bit. But what happens when we push production past that equilibrium? That leads us right into the final phase of their interaction, Rule 3, the ascent. Let's look over at the right side of the graph now. Observe the spatial relationship beyond output level OQ2. Once we cross point L, the marginal cost curve suddenly shoots up and physically sits above the average cost curve. Consequently, during this entire range beyond OQ2, the average cost curve is now rising. We are basically witnessing a shifting gravitational pull here. When marginal cost is greater than average cost, the average cost rises. Because the cost of adding an extra unit has suddenly become way more expensive than the average cost of all the previous units combined, that pricey extra unit drags the overall average upward. So, now that we've broken down all three phases on the graph, let's synthesize these rules into one cohesive economic law, the minimum point rule. Let's see how this builds our complete picture. If you need to map this out step by step, just remember these three things. Step 1, MC starts below AC,
acting like a downward gravitational pull that causes the decline. Step 2. MC cuts AC from below at the exact minimum point, where average cost stops falling. Step 3. MC ends up above AC, completely reversing that gravitational pull and causing the ascent. Because the AC curve absolutely must rise eventually due to the law of variable proportions, the MC curve is essentially forced to cut it from below to become the higher value.
If you take away just one thing from this explainer, make it this unforgettable pattern. If marginal cost is less than average cost falls. If they're equal, average cost is at its absolute minimum. And if marginal cost is greater, average cost rises. This dynamic is an absolute, ironclad rule of production cost analysis. This whole dynamic really shows us the immense power of the marginal cost curve. It quite literally dictates the direction of the firm's average cost. It's driving the car here. But that leaves us with a pretty provocative final thought. If point L represents the absolute lowest possible per unit cost of production, how exactly does a firm leverage that specific sweet spot to maximize its overall equilibrium and profit? Well, we'll leave that puzzle for our next explainer. Thanks for joining me today. Keep visualizing those curves, and I'll catch you next time.